let's take a look at D. If I look at the 14 and the 15, there's nothing that they're both divisible by, so there's nothing I can do with that. But I can start by looking at my x and my x squared. It means both terms have at least one x that I can pull out, at least one x. Then, let's look at my y. So I've got a y and a y squared, so I can pull at least one y out because both have at least a y. And then let's keep on looking. We've got a z in both, so I can pull at least one z from each term. And then our leftovers get put inside of set of parentheses to save for later. So I'm pulling out one x, one y, and one z. So if I pull out one x, one y, and one z from the first term, then I'm just left with the 14. That's okay. Minus, I'll carry down the minus. Pulling out one x, one y, and one z leaves me with just the 15, an x and a y left. But that's it. Notice those two pieces that are inside have nothing in common, so I got everything out that I could. And that's my final answer in factored form. On this next problem, on problem E, we've got an x cubed y to the 6th, z to the 9th, added to an x squared, y squared, z squared. Again, the goal is to factor. We can't add these because they're not like terms, but we can look at each of these pieces individually. So let's look at the x cubed and the x squared. Both pieces have at least two x's, so I can pull out an x squared. Then, continuing along, I can look at my y's, a y to the 6th and a y squared, which means each piece has at least two y's, so I can also pull out a y squared. And let's take a look. Z's, we've got a z to the 9th and a z squared, so they both have at least two z's, so I can also pull out a z squared. So I'm going to pull out two x's, two y's, two z's from each and every piece. And then whatever's left over, once I pull out the two x's, two y's, and two z's, will go inside of my parentheses. So if I pull out two x's from the x cubed, I still have an x left over. Pulling out two y's leaves me, well, I had 6, will still leave me with 4 y's. And I had 9 z's, pulling out 2 of those will still leave me with 7 z's. I can carry down my plus sign next. Now my problem with my last piece is, if I pull out 2 x's, 2 y's, and 2 z's, it appears like I would have nothing there. But remember, what's always hidden out in front of any term is a hidden 1. So I will still have the 1 that's normally there, that's hidden. So I've got my final answer of my x squared, y squared, z squared times x, y to the 4th, z to the 7th plus 1. And again, notice what's my leftovers inside have nothing in common. So I did get indeed the greatest common factor, and I'm done with this one. In problem F, let's take a look at F, and let's talk about the numbers first. We've got a 12, a 2, and an 8, which are all divisible by 2. So I can factor out a 2 from every piece. Then let's look at, we've got an a squared, an a cubed, and an a cubed. So all the pieces have at least two a's, so I can pull out an a squared. Then let's look at our b's. We've got a b squared, b cubed. So that means all of my terms have at least two b's, so I can also pull out a b squared. Now let's look at my last and final part, which is looking at the x's in each piece. And if I look at the x's in each piece, let's see, x squared, x cubed. Notice that each piece has at least two x's, so we'll also include an x squared. And then whatever's left over will be inside of parentheses. So this means I'm going to be pulling out a 2, an a squared, a b squared, and an x squared. So first of all, starting out with the 12, 2 goes into 12 and will leave us with a leftover 6. Pulling out 2 of the a's means they'll be gone. 2 of the b's, those will be gone, and 2 of the x's will be gone. So we'll just have the number 6. plus, now pulling the 2 out of the 2 means the 2 will be gone here in the next term. Pulling out 2 A's, well, we had 3, will leave us with an A in that second piece. Pulling out 2 B's and 2 X's, though, we'll get rid of both of those. Then we can carry down our minus sign. Next, 2 will go into 8 4 times. Pulling out 2 A's, well, I had 3, will still leave me with an A. Pulling out 2 B's, I had 3, so that'll still leave me with a B. And pulling out 2 X's when I had 3 will still leave me with an X. Just like before, notice each of those 3 pieces, we pulled out the 2, the A squared, the B squared, and the X squared from each piece, and that all 3 pieces, when we're done, have nothing in common. That's how we know we got everything, and we did get the greatest common factor, and we are done. Let's start with problem G. In problem G, let's take a look at let's start by looking at the numbers. We've got a 6, a 24, and a 12. Notice that they are all divisible by 6, so we can start by factoring out a common factor of 6. Then we can also look at our x's. We have an x squared, an x cubed, and notice in this last piece, we have no x whatsoever. This means I can't pull an x out of each and every piece. If you can't pull something out of each and every piece, you can't pull anything out. It has to be able to be pulled out of everything. So I can't pull out any x's at all. But notice on the first term I have a y squared, on the second term I have a y squared, and on the third term I have a y squared, so I can pull out 2 y's. And let's look at the z's next. Well, notice on this first term we have no z's, so I can't pull out any z's if I don't have any in one of the terms. So let's see what happens when we pull out the 6 and the y squared, and let's see what's left over inside of our parentheses. So let's start by pulling out the 6 and the y squared from each and every piece. So notice if we pull out a 6 and the y squared from the first piece, pulling out the 6 and the y squared only leaves us with the x squared. On the second piece, we have a plus, and 6 goes into 24 4 times. We're pulling out the 2 y's, but nothing else, so we'll still have the x cubed and the z. Minus, and the last one, again, 6 goes into 12 2 times. We are pulling out the y squared, the 2 y's, but that will still leave us with the 2 z's, so z squared. Notice that all 3 pieces, when we're said and done, don't have anything that they have in common between all 3, so we did indeed get the greatest common factor, and we are done.